Hi, I'm Pat Kelly. Okay, and in this problem, they give us the probability density function of 1/50th x over the interval 0 to 10. They ask us to draw a graph of the function and then also to find each of these four probabilities. So we'll begin by drawing the graph on our axes here. And you can tell it's just a linear function, an intercept of 0, and a slope of 1/50th, so mine might not be perfectly to scale, but I need to go from 0 to 10 on the x-axis. I'm not going to be going very far up at all on the y-axis. It's really only going to end up being 1/50th. So our slope is going to be 1/50th. So you have this probability density function, and we use that to find each of these probabilities. I mean, we'll be able to see that in the drawing. The first probability they ask us for is the probability that x is between 0 and 6. In order to solve these probability problems, it ends up being a definite integral, where your limits of integration are just those endpoints of the compound inequality. So we're going to go from 0 to 6. And the integrand inside is just your function, 1/50th x dx. We'll have the same setup for each of these problems, but it's a definite integral from end to end with our f of x function on the inside. Now we need to evaluate the integral, 1/50th antiderivative of x, and since it's a definite integral, we're going from 0 to 6. So this equals 1/50th. 6 squared, 36 divided by 2 is 18, and then minus 0. So this is just 1/50th times 18, which equals 0.36. So our answer for part A, what is the probability that x is between 0 and 6, equals 0.36. If you want a visual for that, the drawing that we've done, the graph here, is going to tell us that if we're looking from 0 to 6, here's 0, let's say that's 6, this area will equal 0.36. That's the relationship here, is the probabilities are our areas, in this case just from 0 to 6. I'll tell you that because if you wanted to, you could confirm by finding the area of a triangle if you want to take a little bit of time to find the base and the height. Base is 6 and the height would be 6/50th if you just plug in x. Should get 0.36 as well. Okay, part B, for each of these other parts, we do the same kind of work as we're looking for the integral from 4 to 6 this time of that same integrand 1/50th x dx. So we evaluate, which ends up being the same work we did in part A other than the limits of integration, this time going from 4 to 6. So we have 1/50th. 6 squared is 36 divided by 2, 18. 4 squared is 16 divided by 2. So we get 1/50th. And then 18 minus 8 is 10. .20 if we want that as a decimal. So the probability that you'd be between 4 and 6, if I redid a little bit of a drawing, shaded between 4 and 6. This time we're talking about a trapezoid, but still the area of that trapezoid would equal 0.20. For each of the other two problems, we do the same setup, definite integral, this time from 8 to 10, and then 1/50th x dx, 1/50th x squared over 2 from 8 to 10. Evaluating 1/50th, 10 squared is 100 divided by 2, 8 squared is 64 divided by 2, so we get 1/50th times 18, or 0.36. Just arithmetic at the end. Our probability that x would be between 8 and 10, 0.36. Last one, same setup, but a couple quick comments about this one. First one is you notice there is an or equal to. Okay, it's strict, this one's a loose inequality, these are all strict inequalities. The only issue is whether or not we include 2. That doesn't matter. You would have learned that the probability of being exactly one of these endpoints of the inequalities is negligible. So this is going to behave the same as the others. I want to do an integral from 2. But another aspect of this problem is it's not a compound inequality. So it says x greater than or equal to 2, but remember we're only looking over the interval from 0 to 10. So we do have an upper limit there of 10. And then I get back into my groove of the same type of problem as the other 3 parts. Is our integral from 2 to 10 of 1/50th x dx and 1/50th x squared over 2. This time with limits of integration of 2 and 10. 10 squared is 100 divided by 2 is 50. 2 squared is 4 divided by 2 is 2. 1/50th, 48. 0.96 as a probability. Okay, so in each one, you notice we just set up the integral as a definite integral. F of x is your integrand, and then evaluate the definite integral at the limits which are given to us in the compound inequality. Okay, hopefully that helped. Thanks.